is Sean Parsons, who's the Managing Director of eLoom, which, in the spirit of the Internet of Things, is a diagnostic development company creating simple, elegant diagnostic devices for the use of point-of-care and home testing markets, which is really important in a country like Australia where there's a whole lot of space with a really few people in the middle, right? Sure. So some of his products include the Respiro flu test, which is a non-invasive, simple and sensitive test for the diagnosis of influenza, which obviously has been pretty bad this year, so I imagine that's gotten a workout. And it's a private company based here in Brisbane. Take it away, Sean.
Thanks very much. Well, first of all, thank you, Kevin. Great speech, absolutely wonderful. I won't be following it up with lots of graphs for the broader audience, but instead I thought I'd tell you a little bit about eLoom and about our story, about the technology that we've created, indeed invented, and talk to you a little bit at the end about STEM and about maybe a couple of things to consider about the future of STEM in Australia. So I want to talk about the biology and the involvement of biology with STEM. So this fellow is probably one of the best there has been of recent years in predicting the future of technology. And through his career at Apple, he placed Apple at the intersection of biology and liberal arts, of technology and liberal arts, technology and creativity. And towards the end of his life, as he engaged more with the healthcare system, he came to the conclusion that a new era was beginning, where technology and biology, or the intersection of those two, was going to be a critical part of the future of innovation. That is really where eLoom resides, is at that junction of technology and biology. Taking a piece of biological information, accurately determining that, turning that into a piece of digital information to enable people to make good decisions about their healthcare, and most importantly, to get better, which is the goal. So, to overview the story of how we got to here, this is a fellow named Stephen who is in the Princess Alexandra Hospital in 2011. He's dying from swine flu, and he's on something called ECMO, which is the last-ditch therapy for isolated respiratory failure from flu. This big blue cable here, or tube here, is taking deoxygenated blood out of his inferior vena cava. It's going through this machine here, which is oxygenating that blood, and then that blood is being pumped back into him through this red cable there. Stephen spent about 3 weeks ventilated, paralysed, sedated in intensive care, and that's his wife Cynthia, and at the huge expense to the Queensland taxpayer, and he survived. He lived, he went home, and is back at work, and very grateful that we went to all of that trouble. The question is, where did Stephen get flu from? He actually caught it in hospital, where he had cellulitis. Someone unknowingly came into hospital, feeling sick with maybe they just thought it was a cold, gave Stephen flu, and Stephen ended up like this. The person that gave flu to Stephen got it from somebody else, who in turn got it from somebody else. And so there was this realisation that the way we break the transmission of illnesses, infectious diseases like flu, is to identify the people who are unwell, to encourage them to get treated, to encourage them to have social isolation, to break that chain, and all we have to do is break one of those links, and Stephen doesn't end up there. And so, my background was as a biomedical science, physiology, a bit of research in developmental neurobiology, postgraduate medicine here in Queensland, some time at the Royal Brisbane Hospital, followed by a bit of time in regional Queensland, including in remote Indigenous communities. And it was, I came back to Queensland, came back to Brisbane to complete my critical care training, which is where I was through that swine flu pandemic. And obviously that pandemic was a very high influx time of people who had flu-like illnesses and had flu. And the realisation was that some of those people would be willing to diagnose themselves with flu, and that doctors were interested in diagnosing them. The problem was the tools that they had. There were rapid tests, but they weren't very accurate, and there were accurate tests, but they weren't very rapid. And so we set out in 2010 to create not just rapid and accurate, but to create great products that doctors would want to use. and products that could eventually transition into the hands of consumers. And so 5 years down the track, and after an awful lot of investment and some very patient, brave investors prepared to back us, we are releasing next year a product called IllumeLab, which is a smartphone-enabled diagnostic product. It's designed for doctors, general practitioners predominantly. Involved in that technology is a whole bunch of new things. A first-of-world fluorescent nanoparticle based on a quantum dot, which is a tiny little nanocrystal. It absorbs blue light and it emits red light. So we can test for these tiny, tiny amounts of red light. The way it works, though, which is not something that the clinicians aren't really interested in the tech. They're interested in the performance and how it helps them in their day-to-day life. So the way the product works, there's a suite of products which will be released next year. For flu AB, you insert that into the test, and the test comes to life. You take a swab from the patient, you put that into a buffer solution, and you apply it to the test. And as you can see there, the test takes between 5 and 8 minutes to give a result. When that result is available, you get a positive influenza, flu AB. In addition to that, you get information on positive influenza tests in your area, which I think links nicely in with the previous talk that we had from Kevin. It's about taking these pieces of data captured all over the country, indeed all over the world, and about bringing them back into a single database and feeding that back to clinicians. Where is their flu? How much flu is there? What is the likelihood that when a clinician does a flu test that it is actually going to be positive? And that information comes back to the clinician to enable them to make a more informed clinical decision. The challenge is getting this inside the consult time, which a clinician has to see you, and about making it simple enough for them to have on their desk to make that usable. The cool thing about our tech is that it can be more than just a test. So the tech can, using some camera technology, can take photographs of moles and upload that to a patient's clinical record. You get the real-time epidemiology, as we spoke about, the ability to order tests and access to a whole range of medical apps, which we can stream through to the device. A Snellen chart is just one of those. The point of this product is about enabling clinicians to make great decisions, to enable their customers, their patients to get better as quickly as they can. About making that simple and intuitive and something which helps them in their day-to-day practice. So that is easy, fast, accurate, versatile, and with overall benefits to the community. So the less people that get flu, the less people we have like Stephen, and the less the total burden of disease is on our community. Okay, so that's our point of care play, and that's the technology we've created to do this. Our ultimate goal is to create consumer use products and to enable this technology to become something that you might be able to use to diagnose yourself with flu, or RSV or strep throat, these common illnesses which are very burdensome on our communities. And there's some really great stuff coming in due course. That same technology that we've created for the IllumeLab product is being, as was discussed, spun into a format for consumer use. And I don't think I've got time to walk through that today, but we as a company are really excited about that and where that's headed. Okay, so my last slide. This intersection of technology and biology, I think, is an important one for the state of Queensland and for our community. I think there are lots of opportunities that exist there, and by being able to integrate these technologies, computer science, engineering, mathematics, biology, the integration of those is going to yield great products, really great products, and from those great products are great companies. So I think Queensland has some wonderful science and some wonderful STEM graduates. The part that I think we could do with more of is STEM graduates that also understand business. So something for us to consider is that combining STEM with business training, and indeed if I was going back to an undergraduate time now, I would almost certainly study science and business. I think the opportunities that would open up for both at the individual level and at the community level would be really worthwhile, and it would place you in a position to be a wonderful entrepreneur, should that be the course you go down. But I think it would also put you in a good place to be a highly sought after participant in a bigger company. So with that, I'd like to wrap up. Thank you very much.